So just a brief context setting on the theme of this panel. See, 10 years ago, we were talking about, that's the first time we were talking about digital technologies, and we said SMAC technologies, social, mobility, analytics, and the cloud. 10 years, about 2013, 14, we started talking about it. Then we had where SMAC became iSMAC, because Internet of Things also got added to it. And a little later, now in recent years, I call this as IE SMAC now, where you got even edge computing also, which has got added to it. And I talk of these technology couples, where you have technologies on a standalone basis when you see, somehow probably it has not clicked. I'll give you some examples of technology, what I mean by technology couples. If you take 3D printing, 3D printing, we have been talking for several years, but it has never come to the prime time as such. It has always been used and is still being used for prototyping and so on, right? But just imagine 3D printing along with generative AI, a very, very powerful kind of a combination. So, today your limited 3D printing is limited because you have manufacturing constraints. Despite design engineers coming out with very innovative designs, you have some limitations in manufacturing. But with generative AI, which can come out with very, very different kind of designs, which can help the product design, whether it's an automotive or any other organization, and coupled with that 3D technology, because 3D technology, 3D printing can print pretty much whatever complex designs are there, which can even handle very complex contours and so on. So these two technologies coming together, will we see a significant kind of a change in the future in terms of product design going forward? I'm just extrapolating the kind of future. Similarly, I'm saying Gen AI and quantum computing. So quantum computing may be about 5 years away from productionizing, but just assume that if you have Gen AI and quantum computing put together, can become a very powerful combination. So similarly, here I'm saying 5G plus edge computing. It's not a technology couple. I'll say a technology triplet now. 5G computing, AI, and 5G with edge computing, 5G and AI becomes a triplet. I'm tempted to say it is a quadruple now because you have the cloud also included. Makes a very, very powerful kind of a combination in terms of unleashing the power of this combination of technologies. So it's not a technology couple. In this case, it's a technology quadruple, I would say. There are advantages and disadvantages of all these technologies, especially edge computing. There are advantages, there are disadvantages also in terms of how much of compute can you really do at the edge, how much of data can you really store at the edge, and so on and so forth. So the theme is all about the combination of these four technologies unleashing power, right? So I will start off with a very general question to all of you all. Probably we can start, Amit, your views first on. How do you see this technology, this new animal called edge computing? And are there some use cases which you have come across, either in your organization or in your industry or outside your industry, which can be interesting for the audience to hear?
I think something that I've not experienced now, but experienced many years back, which I see now with the advent of technology, and as you mentioned, 5G, cloud, a faster processing and everything being available. One of the perfect use cases is for people who are out away from the mass land base, or the most exciting piece that I can think of is remote medicine, telemedicine as we can say it. Use of technology, use of faster speeds, faster decision making based on data, cognitive intelligence,
Yeah.
Remote operations, physical operations,
Yeah.
that people can do. That's a perfect use case of all these technologies coming together. The person can be doing an analysis based in US, but with complementary data available in different locations of the world, and 5G speeds available, telemedicine, remote physical operations become a very, very critical or important use case. You don't have to run behind technology to do, run to hospitals to do this. A lot of these things can be done remotely as well.
Yeah. So before I come to Haryant, since he was talking about use cases, there are a few use cases which I thought I'll share with you. A classic example of autonomous cars is a very good example of edge computing. Whether it's LiDAR technology, cameras, everything is done at the edge. The second example is connected trucks or connected cars or whatever, right? And from my experience, I've been into it. Every truck which is today running on the roads here in India is connected. Whether it's a Tata Motors or an Ashok Leyland truck, everything is heavily connected. The device which is fitted on the vehicle is a mini computer by itself. It's got its own compute, it's got its own storage, and you have a lot of algorithms which are running on the device. For example, harsh braking. When the driver presses the brake very hard, right? That data is captured and then processed. The algorithm runs on the device itself. It does not go to the cloud, right? It's all rapid acceleration. Suddenly he presses the accelerator. That is also sense data is captured. And whether it is really rapid acceleration, that algorithm runs on the device itself. A very good example. And from a retail industry, for example, take Amazon, right? You walk into an Amazon Go or whatever. You have cameras which are there, which captures who the customer is, and you have an algorithm running there itself at the edge itself, identifying who the customer is, and the customer seems to be standing in front of some shelf, right? And immediately you sense that and then shoot off some kind of promotion, some discounts or whatever, right? Without all that data getting into the cloud, or everything happens out there. There could be several use cases, which includes even the healthcare also. So I'm imagining a day where we have sensors in our body. It is already there for all the 40 plus people to sense your blood pressure, your sugar levels, and your stress levels, or whatever it is. It's there. But it is on the edge, but the compute does not happen here. So today, I'm imagining a day where a diabetic patient, I'm not diabetic, but still, I go to my friend's son's wedding reception, and then I have a good dinner, and then I go to the dessert section, some good rasgullas and gulab jamuns are kept there. I have one rasgulla, and immediately my sugar level is thing, and my sensor has captured that. And I get a call, immediately the data is transmitted. My healthcare service provider calls me and says, "Sir, don't take the second piece because your sugar levels are already up." But if that were to happen at the edge, where the compute happens here itself, rather than the data being beamed out there and so on, that becomes a very good example. And that I don't think, the day is not far off when you're going to have technologies like that. So you have a lot of these innovative use cases coming. In the construction industry, Arihan, from which you represent, what are your views on edge computing? Are there good use cases which probably Prestige is using, or the construction industry is using?
Yeah. First of all, thank you for having me here. From edge computing perspective, Prestige is forefronting, adopting and leveraging the edge computing in terms of transforming our real estate. We have implemented edge devices in various portfolios, right? Which is enabling us to capture data real time. It is also helping us make decisions faster. It gives us, let's say, immediate feedback about how the facility is being maintained, and able to control that facility better. And I think with control systems, we are also able to manage it. Now, if I have to put that in perspective, right, I'll take a few examples which we have implemented, I think 1 year back when it started, and we implemented in couple of our commercial properties, the edge devices, capturing data with respect to how the temperature is fluctuating across the day, right? And at a real-time basis, based on the number of head counts in the spaces, the temperature automatically changing, right? Again, there is always manual interventions, but that's a great way to, let's say, reduce, or I'll say great way to optimize our energy consumption in the space of commercial management of our buildings, right? I think this is just one of the examples which I have put in. We are at the very initial stage of adoption of edge computing. There is a lot we can do in terms of building intelligent buildings and powered by AI ML. But yeah, we are there, and we are having that in our roadmap as well.
Arun? Your experience, you come from the logistics industry, right? How is the logistics industry looking at edge computing? Are there some very interesting use cases which you can share?
Yeah, thank you, Ian. So, logistics company are the pioneers in consuming the edge computing platform altogether, right?
Yeah, yeah.
So, DTDC being an legacy Indian company with 35 years of the legacy, we carried our own transformation journey. Since last 3 years, the focus, what we put on technology, and now followed by AI comes into the game, we were putting a lot of focus on changing my operations on the ground, how my edge computing can change. So instead of doing the traditional way of doing the last mile operation, we completely deployed handheld devices or a kind of a POS device, but it is a more sort of scanning devices, completely route-based automation using the edge devices, the rider app completely on edge data, optimizing the route, optimizing the delivery, optimizing the performance of a delivery person. All this again tacks back to the operation on.
But does the compute happen at the edge?
It does both. It does both. That's what I was just trying to quantify that one. The first compute happens on the operation floor. It happens at the edge itself. Okay. That's where I was just trying to correlate when you mentioned, is it possible to have so much of data on the ground and then how I'm going to manage such a data? That's the same pain I'm going through as well. When very specifically on the sorting area, when we have like hundreds of sorting arms, when the compute happens here and the data stored there, and getting that data back into the central system to processing it and having the same data back into the Riders app, that's a complexity when it comes to the negative aspect of the edge computing. But the computing, for example, DTDC is second largest in the pin code after Post Office of India. We support 14,000 pin codes, which means somewhere down in the Himachal Pradesh, deep inside, if someone wants to have a delivery or a pickup, we have our presence over there. So if that is the case, when I go take a booking or deliver a parcel, both the entire data platform happens over there only. Okay, I take your booking, and those cases we might not even have internet. So I can't wait for internet to be available on my edge device to go back to my cloud and
store
perform.
and forward.
Exactly. So all the compute happens on the edge, and once I come back to the place where I have an internet, and then data syncs back to the operations floor.
Yeah.
This is on that aspect. There are several other use cases like logistic adopts, very specifically on the use cases for the temperature controlled containers.
Yeah.
Very specifically for the pharma companies which we support. The complete transit of the container has to be, the truck has to be monitored with the temperature sensor. So these use cases are highly achievable, or specifically during COVID time. DTDC been very supportive for all the COVID vaccine transit across the India. And that was possible because of this edge solutions where we could able to have a temperature control solution. But these are all few samples I can say, but there are a lot in the roadmap, and we are looking forward to have a big changeover, having Gen AI getting into the space for improving the customer experience.
Amit, from a hospitality industry perspective, which you represent, how is this working? You know, what are the trends that you see in the hospitality industry?
So yeah, first of all, thank you for having me here. So edge computing, if you see, its a power is low latency. This all around. It's not just I am able to connect it other devices, but latency is crucial. And in hospitality, there are many touch points where we use edge computing very well. Because if you see, there are different system integrator, but they should all talk to each other.
Yeah.
So if latency is not low, then maybe your response will come late until the time that service maybe not work perfectly. So what do I mean? Say if I'm opening a door, guest room, and at the same time, how I'll see that curtain should also open. But both are different vendor, different hardware company. So latency matter here. If low latency communicate, so processing should happen at edge level.
Correct.
So that experience I can give to guests.
So what will be this combination of edge and 5G put together?
Yes, so,
It will be a
and there
very
is
powerful.
nothing going outside and then everything happen. And if you come to restaurant sites, so we are maybe SaaS-based application, we have to go for cloud and all. But my billing processing should happen here. I don't depend to the network, but only reporting, menu engineering, I can go for cloud and fetch the data. But the instant billing, because guest will not wait.
Yeah.
So that is the processing required at hotel site.
Okay.
So many use cases we have that.
Yeah.
Thank you.
So Jitender, from a Ruckus perspective, you heard all the customers talk about use cases and so on. What is Ruckus as you, what is it that you're hearing from the customers? What are you seeing as trends? And also talk about those new launches which have done some very, very innovative solutions on the Wi-Fi 7 access points. And how is it different from the earlier version?
Okay. So thank you very much. First of all, thanks for this invite and good insight from the fellow panelists here. So I will tell you, right, see, when we like say edge computing, right? In edge computing, what is the vital piece, which is network? If you look at the definition of edge computing, where people, device, and the things connect and communicate over a network,
Yeah.
right? So networks become a very, very vital piece here, and where like Ruckus networks play a very decent role. So if I take the example of like the hotel industry here, so you have got like say in this hotel, you have got like say temperature sensors, like cameras, or like say you have got like motion sensor, occupancy like sensors, all those things, right? How can you connect these like say things to the edge, right? So edge in this case can be a Wi-Fi access point, right? Because all the access point which is coming in the market, especially from Ruckus networks, other than their 2.4 and 5 gigahertz radios, are also coming with a third radio which is called IoT radio, right? You can connect any kind of a device on BLE, Zigbee, or any kind of a third medium. Okay, so the innovation what is happening here in the industry here, you have to look at right how the trend is happening. Till 2019, right? On these access points, what was connected? It was my mobile phone, laptop, and desktop. Post that, what is happening here now? You are also connecting all these Internet of Things IoT device. If you see the trend here, the forecast is that by 2025, 50 billion devices will be connected to the networks. 50 billion. Out of those $50 billion 50 billion devices, right? 75% will be the IoTs, the things, right? So this is changing the dynamics. What happened here in this scenario here, now you need a more on your edge, you need to innovate. You need to have an intelligent edge, which can be your access points, anything, where you connect your device. So in this scenario, right, we have come up with some kind of a things, right, new access points, where people demands more bandwidth, right, like Wi-Fi 7, right? If it is like say innovation for almost 25 years, we have been stuck with 2.4 and 5 gigahertz spectrum, right? Now 6 gigahertz spectrum has recently opened in some of the countries, not in India yet. So this 6C innovations has happened, Wi-Fi 6E and now Wi-Fi 7 is already there. So for enterprise grade networks, we can offer you the Wi-Fi 7 of the self, right? But in India, you can't use it because government of India has not opened the spectrum here. But what happens here when you have this Wi-Fi 7, there are lots of uniqueness is there. Some of the things called like say MLO, multi-link operation. When we were using Wi-Fi earlier, we were having two radios, 2.4 and 5 gigahertz. What was happening here when I had to connect my laptop or my mobile phone, I was using only one radio. Second radio was redundant, right? Now in the Wi-Fi 7, when you have a MLO, right, you have got 2.4, 5 and 6 gigahertz radio, okay? So now the user or the device has the ability to use two simultaneous radios at a time. So you have more bandwidth. That is the first thing. Second thing, what is happening here, like say not, because see now you have got Wi-Fi, lots of devices are there, lots of interferences there, internally, externally. So something has come up in this called like radio, like say radio management. The radios which is there in the Wi-Fi, in Wi-Fi 7 is so powerful, like the AIML capabilities is built in here. So you can do lots of this modification at your own, right? The radios are capable of doing all these things. The other thing is that all these Wi-Fi 7 is coming with 10 gigahertz, like say 10 gigabit of backhaul, right? So when you connect your access point to the switch, you will have a 10 gig pipe so that you are having more bandwidth, right, to the user. The use cases are very simple. Like for example, you took the example of 3D printing or the manufacturing.
Yeah.
Lots of devices are there, right?
Yeah.
You need bigger pipe,
Yeah.
right? Because currently limitation of the Wi-Fi, it's a shared media, right? In one if one access point is there here, right? Maybe we have got 200 guests sitting in this particular room. So this particular access point, particular bandwidth will be shared between 200 people.
Yeah.
So in that scenario, this Wi-Fi 7 is solving that problem,
Okay.
right? And giving you the advantage to look at, right, how you connect all these things and provide more reliability, more bandwidth. So this is the way, right, things has happened
Yeah.
in the mobile industry, like 2G, 3G, 4G, 5G. It is giving you more bandwidth. Same thing in the Wi-Fi industry. Now Wi-Fi 7 is up there.
Yeah. The next topic is on the challenges that you face in the implementation on edge computing. And I'll highlight one challenge is on security becomes a challenge. The reason is anything that is decentralized, distributed, security becomes a problem. And the example here is we had this G20 summit in Delhi a few months ago, last year. We hosted about 20 world leaders. They were all housed in about 20, 22 different hotels, which are all distributed. So you had a big challenge. India had, or the Delhi administration, the central government had a big challenge in ensuring the security. They're all world leaders. It's our responsibility. They are our guests. So the only option for them to secure them and keep them safe was to cordon off, right? So almost half of Delhi was cordoned off, like almost a partial lockdown. Nobody can enter, right? And that's the way, they provided kind of security. So you have a similar kind of, the more and more distributed it is, providing adequate security, especially in an era where you never know when you could be attacked, when a breach can happen, right? And that's only increasing today. That's one of the challenges. So what are the challenges? Are there some tips, do's, don'ts, some things which you have for the audience in terms of takeaways, in terms of how do you mitigate these challenges? I gave you an example of security. It could be other challenges also. The other challenge probably is you can't have that much of compute power and storage power at the edge, right? There is only so much that you can have, probably. What are the other kind of challenges and any thoughts on this? Any spin? I'll open up this. So,
Sorry. Actually, you are bang on. Security is the key challenge. Anyhow, if you look at the compromises happened in last 2 years, it has been told that the key compromises, the key element of the contributor was an IoT platform. Okay, so definitely security is a challenge, and there are a lot of mechanism we are working upon to bring in, putting up measures to have a layered security approach to protect the edge devices, starting from the BYOD or handled kind of a devices to an arms running in the operation flows over there. But the key challenge, what I have looked at is very specifically, which I felt it was little difficult for me to address was on video analytics platform. So there we run like a video analytics platform across all our warehouses, and we understand, right? We capture all the CCTV feeds, load into one NVR, and then that has to go to one platform which has to convert into an analytic engine,
Yeah,
right?
yeah.
So storing the data locally and then pushing the data to the analytic engine,
Yeah.
we need a huge bandwidth.
Yeah.
So if I need 100 Mbps to run the entire operation, I need 200 Mbps bandwidth to do this analytics alone. So mitigating that was not an easy task. Then we need to, that's where Edge came to rescue us. Otherwise, I should have pushed everything to the cloud and then processed everything. Now I put an Edge device over there where the actual compute happens there and metadata goes to the cloud. Now, when the compute happens here, if at all there is a network interruption between this transaction, the analytics available on the cloud to put, for example, a fire accident happen all in sudden, and there is an expectation of an alert goes over to someone. Now the edge device is not having any communication to the cloud network. No alert goes into the layer.
Yeah.
Okay, so these are the risk which anyway, we know, right, we
Yeah.
put all kind of HA backup mechanism to ensure that the data gets pushed in, but these are all open risk and challenges we need to live with at this point of time consuming these kind of edge technologies.
So, I mean, the takeaway is even if you want to do some deep analytics, right, which might call for a data which is not there on the edge. You need to kind of blend the data which is on the edge and the cloud data also, cloud or on-prem or whatever it is. Then it becomes a challenge for you, right? Any thoughts, Amit and Harian? Quick thoughts before.
Yeah, I think security is one of the which is covered, right? The another one is how much autonomous power you want to give at edge, right? I think within the organization, we felt that's always a debate how much control you give at the edge. So somewhere in our journey, we decided that uh, they should have, they should be able to make, the edge devices should be able to make real-time decision making based on their local feedbacks or the responses, while the policies and controls coming from the centrals, right? And also having a real-time analytics which we can track and respond immediately and control any anomalies happening at the edge devices. So I think how much autonomy is to be given to the edge devices, I think that's another one of the critical pieces which vary business to business
Absolutely.
and
You'll have
how
to
we use
balance
it.
that out. Yeah. Yeah. Amit?
I think there are, from a security standpoint, a lot of use cases. You need to build, as Aryan said, build intelligence at the endpoints so that they're able to understand and take decisions and not permit you to do anything wrong. Okay. One example that we saw a couple of years back on video cameras was that they will not record everything that is happening,
Yeah.
but they will record an anomaly. If a person is falling, they will record that thing and maybe give a call to somebody. So at the edge, the intelligence was built in.
Correct.
In computers, we have EDRs, etc., that have been implemented. Uh, enough amount of intelligence is fed into them when they are connected.
Yeah.
So even when they are not connected to the internet, they have the capability to stop something malicious from happening. On a lighter note, you spoke about rasgullas with diabetes. Maybe if the edge computing happens that well, that your wearables have a the watch is connected to your sensor. Maybe the watch will not allow your hand to go into that container to pick up another switch. So in fact, my son has built something on wearable technology. He's written a paper on that. So everything is available in these watches these days. You have the environmental conditions. You have the humidity available. If you play in mud, you can have the garment can have a sensor.
Yeah.
So you don't have to tell the washing machine how much detergent to use. The machine should be talking to the T-shirt and deciding what to use.
Yeah. Yeah. Oh,
So
very
intelligence on
interesting.
the edge devices.
Yeah, yeah. Looks like fiction, but generally fiction becomes a vision, then it becomes a dream, then a vision, and
Star
then
Trek,
finally it
telephones,
becomes
cell phones.
something which is a reality. Yeah, that's the thing. The Jitender, how do you final thoughts on this? How do you see this technology moving forward? Considering that this edge is also like even in organizations you find centralization, decentralization. Suddenly management decides that we will decentralize. You push all the authority, decision making authority to the edge. But of course the edge here it stands for different. But I'm saying push it to the sales guys. Let them make the decisions and so on. And then suddenly you find there is some fraud, something happens. They will roll it back again. So your delegation of power will again, DOPs will all change again. I could give a very, very rudimentary example, but is this technology here to stay? Or considering the challenges and all that, how do you see the proliferation?
Definitely, technology is going to stay. There's going to be lots of transformation there, right?
Yeah.
So in today's scenario, when you look at the overall things, right, in the network side, see all these new devices, right? What like in a manufacturing environment, when you are doing the convergence of IT plus OT,
Yeah.
right? It's a new challenge for the CIOs as well as the CISOs now. Because earlier the CIO was only managing the network and the data center. Now suddenly, right, this OT network is coming, right? Onboarding to your particular thing, right? Suddenly you have to see, right, how these are new creatures. Okay, these OT device, which is like sensors, has got like say from different vendors. Every vendor has a different panels, right? Different console things. So this is creating lots of things. So there are lots of solutions are there in the market which can protect, right, your network both from IT and OT. Okay, that's why IIoT is there. Okay, so I think in my opinion, right, edge computing, definitely you need to build your edge more intelligent so that decision making happens at the edge level, because you can't send, like as you gave an example of like the car. If a decision is going to happen in the data center DR, which is sitting somewhere like in say San Francisco, right, it will take time. So you need to do the decision at the local level so that you have a less latency, right? So what I always feel, right, in this scenario, like you have to sense, then you have to process, and then you have to act.
Yeah.
That's the way we have to build the ecosystem.
Yeah. So thank you. I think we are run out of time. So thank you for your wonderful insights. Can we all put our hands together for the panelists for these wonderful sharing these wonderful insights? Thank you very much.